Hey everyone, welcome to our first Sysdig LinkedIn Live session. My name is Eric Carter. I am the Director of Partner Marketing focused on cloud ecosystem here at Systick. And first of all, thank you very much for jumping on with us today. Again, like I said, it's our first one, so we're excited about seeing how this unfolds. Today, my special guest is a gentleman named Pavan Shankar. Pavan is the Director of Product Marketing here at Security. Pavan, thanks for being here to talk about security, seeing and securing containers on AWS Fargate. Maybe you want to say hi and maybe say a little bit more about you. Yeah.
Hey, Eric. Really excited to be here and really excited to talk about all things security on AWS.
Cool. And one of the things is I want to encourage the attendees to ask questions. There's the interface there that should allow you to do that. And along the way or toward the end, at least we will try and answer those for you. Pavan, why don't you jump off the slide for a second and let's have a look at what you look like today. I know, maybe stop sharing for a second. All right, cool. There you go. I just want people to see our smiling faces, like we don't have a tuxedo or a jumpsuit on. Let's get rolling. You know, part of the purpose here today is to basically talk about securing containers, and we'll get into the focus on Fargate in a second. So what I wanted to start out with is, you know, why is this an important thing? What are the challenges? What are the needs around securing containers that we are encountering or seeing with our customers? Maybe set the stage for us, Pavan.
Yeah, absolutely. So, as we see customers, first of all, are really moving to containers and Kubernetes in production, right? There's a huge shift from re-architecting their applications when they used to be on monolithic based, applications to now moving towards a CI/CD and a microservice model, right? And leveraging containers makes a whole lot of sense. It's modular. It has some inherent security capabilities, and it's just easier to ship applications faster. Right? So platforms like EKS, ECS, Fargate are really starting to pick up momentum as DevOps teams and cloud teams are starting to leverage them to deploy applications more rapidly. But the challenge still remains is how do you secure these containers and these applications that are running in your AWS environments? So a lot of times when I talk to customers, they're typically starting off with use cases such as image scanning, where that seems to be a great step in addressing security, where you want to make sure that you're ensuring that your container images are free of vulnerabilities or potential misconfigurations that your developers might be introducing unknowingly, perhaps, and really making sure that these images are as clean and as safe as possible before you deploy them, in production. So image scanning is a great example of a common use case I hear from customers that they're looking to address, and we'll definitely talk about that in more detail. But other use cases, as these teams start to get more mature with Kubernetes and container environments in AWS, are use cases like runtime security. network segment security, incident response, and forensics. So really, those kind of set the stage for an overall container security framework that we believe security teams and DevOps teams must follow.
Gotcha. So a number of places where we can do kind of due diligence and put security into the process to secure
Hmm.
what's happening, right? And so today, since we are focusing on really on securing the build pipeline, um, what really is available there? What are the different types of scanning being used, or any other things that um, help us get a handle on that, first of all, and then prevent deploying things
Yeah,
into production that are vulnerable?
yeah, that's a good question. So let's you know talk about this in a slide, and it'll be easier to explain this kind of whole architecture of how we think scanning should occur, right? So when we think about scanning, it's important to consider it, as you said, in the build phase, right? Securing the build, so pre-deployment, as well as at runtime. All right. So when we think about scanning, we are really thinking we're really thinking about scanning your container images wherever they are, right? So whether they're in the CI/CD pipeline, you want to make sure you're scanning your images as they're being built in the registry. If you're using ECR, for example with Amazon, you want to make sure you're scanning your images that are sitting there as well. And then as you start to think about platforms like Kubernetes or EKS, really leveraging some of those native controls, like admission controllers, for example, in Kubernetes, is a great way to prevent the deployment of an image that does not meet those security policies. Now, why this is important is because a developer, let's say in your organization, bypasses the pipeline because they're in a hurry to deploy and try to go directly on EKS and deploy. This admission controller is an extra step to prevent that, right? So it's a preventive mechanism. And then at runtime, it's also important to not forget about that, because what happens when a new vulnerability comes out, or a new, a zero-day attack can be leveraged using vulnerability in an image that's running, or a new vulnerability. So really making sure you're continuously evaluating those images that are running for new CVEs and vulnerabilities, and scanning continuously on the running node. So these are the key areas, Eric, where we feel and we believe that you must embed scanning into your CI/CD process from deployment to runtime.
Gotcha. So there's a whole chain here, and
Mm.
the last part is interesting because we were happy yesterday, everything checked out. We've put a image or a container is now running in production. But what you're saying is, today maybe a new vulnerability shows up, and we want to have insight into that as well, right? So that's what you're saying we can actually achieve here as well, right?
Yeah, exactly. And let's say you're a great developer and you check off all these boxes, right? In the left, but then what happens when something new occurs? We can't blame you, right? Right. We got to make sure we scan.
Yeah. Now, is that disruptive to the production environment, Pavan, or is it just, how does that happen that we understand the new CVE applies to something running?
Yeah, it's a great question. So, we provide out of the box policies from a scanning standpoint, right, to make sure you're following Dockerfile best practices, compliance standards like NIST and PCI, right, that really define a set of conditions and security, criteria for your developers to meet, whether it's vulnerabilities, misconfigurations, right, other not following best practices, and so on. And then, if we see something in that's running at runtime, we will automatically alert you. So it's not disruptive, where we won't stop that image. But what we do is immediately notify the right team, right? And that's the important part, Eric, because a lot of times it's not enough to just say you have 100 vulnerabilities, but what's really important there is the context, right? So where does that vulnerability lie? Which application is that vulnerability mapped back to? Which, in Kubernetes, which namespace or pod or service does it belong to? So really tying that last mile helps your team not just know that there's a vulnerability, but okay, this is the team that is responsible for fixing that, and they can rebuild that image with minimal downtime.
Got it. So how does that happen? I mean, where's that information coming from so that we know who owns the particular
Yeah, so
source?
it's really coming from the context from your AWS environments, from your Kubernetes environment, so the metadata that we collect, right? So now you can say if there's this specific CV that's a high severity CV in US East 1 region, right? In AWS on a specific EKS deployment or service, right? Really mapping that back using the metadata and the context allows you and your DevOps teams to identify exactly where that vulnerable image lies and which team or application does it belong to, thereby identifying the right teams.
Got it. So maybe I'm the Java application owner and that shows up in my containers, right? You can let
Right.
me know right away.
Right.
Yeah.
And the alerting tools are that we plug into, right? So Slack, SNS, any of those your tools that your developers love, we integrate with and can notify that team, so they can go about fixing it. But one kind of key difference here from other scanning tools in the industry is really this capability around inline scanning that we have really throughout this process. So when we think about inline, what that really means is you're scanning directly in the environment that you're in without sharing the image outside of your customer environment. So typically you would have to, today share, send your image to a staging repo or share your registry credentials out, right? Inline scanning just basically says your image is fully in your control. The scanning happens directly in your environment, and only the metadata about the scan results get sent back to a tool like Systick. So we have no control or access to your data. So this is a safer approach to security and scanning, which a lot of our customers are starting to adopt, and really it's becoming the preferred route for image scanning.
Got it. Well, today our focus is really on AWS. So how does that apply to AWS? What are the specific ways we're supporting these kind of workflows for AWS customers?
Yeah, so in the CI/CD phase, we can integrate with tools like AWS Code Build, right? If you're using that, we can scan your images there. If you're using ECR, the registry, we can scan in the registry. At runtime, obviously, the image context that we talked about a lot, right? The runtime context, that's how we can identify. So if your images are running on ECS, EKS, right, EC2 instances, um, any of those flavors, we can support that as well.
Right.
What I've been hearing about a lot recently is Fargate, right? So a lot of times customers are asking us about have been asking us about Fargate, rightfully so, because Fargate just makes it a lot easier for customers to deploy fast because their DevOps teams and developers don't have to worry about the underlying infrastructure, right? It's giving you a serverless front end with just a bunch of containers that are orchestrated for you that you don't have to manage. So it makes it much easier to run Fargate tasks and continue to deploy. And we've actually added Fargate scanning capabilities. So that's something that we launched back in September, where we added this approach to this new and unique approach of inline scanning that I talked about to scanning Fargate containers, right? So how this works is, your developer, let's say they run a Fargate task using some base image like Redis, for example, right? That event of that start task gets registered in EventBridge, and Systick consumes that event from that stream and identifies the image that's being referenced, right? The digest, the tag, and all of the metadata, and then kicks off an ephemeral task in AWS itself via AWS Code Build to scan that container image. So notice, Eric, that this is all automated, right? Like your developer runs that task, we automatically see that task, map it to the image that's being referenced and scan it all within your AWS cloud. So your image never leaves AWS, your data never leaves, your credentials never go out. All that scanning happens locally in AWS, and only the results about that image and the vulnerability information gets, the report gets sent back to Systick where you can actually see.
Yeah, what's cool about this is it kind of maps right back to what you were saying earlier, where sometimes developers will get kind of in a hurry to push something out, right? It sounds like this would catch those kind of image or those kind of task requests and make sure that things were properly kind of
Yeah,
scanned, right?
true. And as you can imagine, right, with Fargate, the velocity increases, right? You're deploying probably even faster with these tasks. So really, you need an automated way to scan immediately and block something from being deployed all within your AWS cloud. And we actually do this under 4 minutes. So we have a video on this that we've recorded that you can watch and check out how fast we can do this in a timed condition.
Got it. Well, and I'm seeing here you're talking about us at Sysdig Secure receiving the scan results. So here's a question: are you able to show us this today so we can have a look at what it looks like?
Yes, exactly. So let's jump into um, a quick demo. I can definitely show you this. Let me know if you can see my screen okay.
Yep, looking good.
Awesome. So let me actually just start in this get started page. So what you're looking at right now is the interface for Sysdig Secure. If you sign up for a Systick free trial, if any of this content or if you've been engaged with Systick, in terms of webinars or other shows, you can sign up for a trial to just really play with the product in action. So you don't have to believe everything I say. You can actually try it out for yourself.
Hey, what's that shirt over there on the right-hand side? It looks like the same one I'm wearing.
Dig deeper, right? See
Yeah,
inside. I guess you completed all your steps.
I guess I did because I got the free shirt. So if that's still a valid offer, hey, there's a Benny for people to jump in
There
and
you
try.
go.
Yeah, we'll talk
Uh,
about trial at the end. But go. Sorry for
Yeah.
interrupting.
So just to quickly mention this, that it's just really easy to get started. Within a few minutes, you can set up the agent, start scanning and doing even more advanced functions around runtime security, into response, and so on. But for the purposes of this session, let's kind of start in the overview page. So what this gives you, let's say you've set up everything, right? This gives you a macro level view of what's going on in your environment, right? So you understand at a high level uh, your security information, both from a build time and a runtime perspective, where you're seeing images that are currently in your registry that are passing or failing, right, by different severity levels, CVEs, critical, high, medium. And then at runtime, you can see those images that we talked about, right? Why is it important to continuously evaluate? Because you might be running into some fail scenarios, and we'll investigate that. And then same thing, CVEs that can pop up that are high critical, that might be affecting your running application right now. And then runtime policy events and benchmarks and compliance that we can also talk about in a later session. But um, focusing for compliance, let's say now I want to go from this macro level into and zoom into a specific cluster. I can pick this demo cube AWS and see and also pick a specific namespace, right? Whether it's this Java app, some other default namespace, or other applications that might be mapped to the namespace. I can identify that. But again, at a cluster level, you can see those images that are passing or failing, and these are currently running right now, right? So let's say I want to investigate. Okay, why are these images failing in my AWS EKS cluster, for example? So then I can jump in and see, okay, there's 72% of images that are failing, and about 30% are passing, and you can actually see all those images that are currently failing. And if I open up one of these images, I can actually see a quick summary of what those stops and warns are, why it's failed, right? The policy breakdowns, and then also investigate the vulnerabilities itself. So I can actually dive into the OS level vulnerabilities first. So seeing the different CVEs, fix, if they have a fix available, what packages that they're affecting, all this information. I can sort it by critical or high to really zoom into the ones that I care about. And same thing on the non-OS level. This image doesn't have those non-OS vulnerabilities, but you can also pull vulnerability information from about third-party libraries like Python pip or Java jar, right, Ruby gem, and so on as well, so your developers can see exactly what those vulnerabilities are. And this is important, Eric, because in our last security report or usage security snapshot, we saw that while developers are scanning for OS vulnerabilities, because obviously it's severe, if there's a base OS image and that has a high severity vulnerability, you could bring your application down, right? But a lot of times developers are not realizing that non-OS vulnerabilities are also important, where 53% of non-OS packages we found had higher critical CVEs, right? So this is a big deal, and this is why you want to make sure you're scanning for both OS and non-OS vulnerabilities.
Gotcha.
So the next kind of step here is, okay, so you're seeing these runtime images, running images that have vulnerabilities. How do you alert? Right? You asked this question earlier. So we can hook into any of these alerting notification frameworks like SNS, Slack, right? Let's pick a better one here. If there's an example of this, yeah. So I can scope it down to a specific namespace or a cloud provider account. You can see all the different tags that I have. Um,
Got it. So
I
this
can,
ties right back to like, okay, let the store front end team know this vulnerability belongs to them, and that can go directly to their notification channel.
exactly, exactly. So maybe this is a dev cluster. I don't really care about it as much, but if it's a store front end, perhaps this is a customer facing application, that team needs to immediately be alerted on this, right?
Yes,
Um,
or front end pub and starts to remind me of things like PCI compliance, right?
yeah, absolutely. And we'll touch on PCI and just connect to that. But that's a great point where a lot of these really have a compliance need as well. And that's how they're thinking about shifting compliance left with image scanning, right? But just kind of finishing this thought here, where you can set up triggers for an image that, let's say it pops up in your environment, it hasn't been scanned before, or you scan and you can notify your team, right? Or if a scan result changes from pass to fail, or a new CV gets updated, right? A new high severity CV comes out, you can notify the right teams. So really easy way for you to set up alerts. But then the real question becomes, how do you make sure you prevent these vulnerabilities in the first place? And what we're seeing a lot of teams do is really shifting security left, right? The shift left concept is real, where customers are scanning in the pipeline in the registry before they deploy. And what we provide is these out of the box policies, right? So Docker file best practices, and to your point, Eric, NIST, PCI, right? Because
Mm-hmm.
teams, if they have sensitive applications that require them to meet these mandates, then they want to make sure that they can scan for those compliance checks early as well, right? So we have those. But you can also customize these for your own security or governance requirements, right? So whether you want to look for packages that are OS packages or non-OS that have, and you can really make it specific, right? To say if an OS package that has a high severity CVE that has a fix available is running longer than 30 days, right? You can basically specify the score, but then this should basically stop the build from occurring, right? Or even checks for misconfigurations where did someone expose SSH in a Docker file or DNS, or the most important one here, which is your AWS access keys are baked into a Docker file, right? That this is a common misconfiguration that a developer unknowingly might be putting in, right? You want to make sure you either warn or stop, depending on your own security control, identifying this, right? And then making sure you can scan for this. That's the most important thing. Or even just other misconfigurations, file attributes, right? So you can see here, single UI that gives you kind of the flexibility to define security compliance and governance policies for your DevOps teams to follow, right? Now, how you can leverage them, these policies really is in the pipeline, in your registry and at runtime. And the pipeline itself, right? I'm showing you a demo of Jenkins, but we integrate with any CI/CD tool, Jenkins, right? AWS Code Build, all those Bamboo, Circle CI. But this kind of gives you the ability for your developer to immediately identify images that have passed or failed. So let's go back to one of these and see if I can open one of them up. So if I see a recent build, I can set up Sysdig Secure to integrate with my Jenkins pipeline here with the native plugin. And you can see the benefit for the developer is to directly see in their pipeline exactly why their build failed, right? You have all these warn actions, stop actions. Why was this build stopped? Well, you can see this developer unknowingly exposed SSH, right? There were some high vulnerabilities in a non-OS package, Python pip, related, some other vulnerabilities. You can see all that here. So again, the developer, before they move on to a different module, they go on to a different aspect, right? They can scan for their containers that are in their pipeline itself. And the same philosophy applies, using these policies. You can scan those Fargate tasks and really ensure that you're able to scan those containers that are running on, based on your Fargate workloads, and scan those images as well with the same policies that you're defining here.
Gotcha. Now, have we, you got any customer examples of what this has meant for a customer in terms of saving time or maybe less false positives, those kind of things?
Yeah, good question. I can actually show you this in this environment where we a lot of our customers are working with us. Some customers are scanning over 10,000 images per day, and it's really we're able to support them at scale, so that really helps.
Mhm.
And then some specific use cases, really, obviously scanning in the pipeline, the CI/CD process, but also understanding what images are vulnerable at runtime. So this is an example of a large Japanese ISP that chose Sysdig about a year and a half ago, and they were deployed over 12,000 nodes on Kubernetes. And what they really wanted was a security tool that could speak the language of Kubernetes,
Mhm.
where they could use the Kubernetes metadata and labels all automatically pulled into their security tool and see their vulnerabilities by that Kubernetes context, right? So for them, they wanted to be able to say, okay, what are the different uh, you know environments in AWS or in Kubernetes specifically going into deployments in pods, for example, and seeing a specific namespace and figuring out what are those vulnerable images within that namespace, and even further going into the service, the deployment, and really organizing their vulnerability information by the labels that they have applied in their Kubernetes infrastructure, which was a deployment, a namespace, a cluster, and a pod, and surfacing these vulnerabilities by that specific hierarchy that they have defined for their business, right? So for us, it was just we were able to do that automatically, and that flexibility to do that allowed them to really report back on which BUs had the most vulnerabilities, identifying the teams that required to fix those vulnerabilities, and so on. So that kind of
This kind of
process.
probably it ties into, and this might be helpful for what you're about to show. There was a question, basically, kind of a best practice opinion question, but for images that contain newfound CVEs, is, is there a recommended grace period to give developers to fix it? Is they have to drop everything and fix it, or is there some best practice? And I guess that's a tough one because it's going to vary, right? I guess if there's a known fix, which I think you'll be able to help show in this report, that probably they want to fix it ASAP. But I don't know if you have any thoughts on that question of like best practice.
Yeah, that's actually a really good question. You know, for example, when it comes to a misconfiguration, we see that 58% of containers are running as root, right? And that is a misconfiguration that could potentially open up the door for a container breakout. They take advantage of a vulnerability in the underlying kernel, and they can get out of that container, do some other you know m- malicious activity. But what do customers actually do? When I talk to them, they're like, yes, we have a grace period. Typically, that's 2 weeks, 3 weeks, depending on the organization that they have in place. But what they do want is that visibility first, right? They want to be able to see what those images are first that are failing. What does that look like? Because they don't want to break anything immediately. So having that grace period allows them to say, okay, here's what's happening, and this is a 2 week period, and then they promote those images to say, okay, this is part of this sensitive cluster. It needs to be resolved within the next 30 days. So this actually is a great question, because think about your patch management workflows that you had for your on-prem or your VM environments, and really building that process into your container workloads, where you can say, if there's a vulnerability that's an OS that is high or critical, right, that have a fix available, is running longer than some certain time, right, across a specific part of my infrastructure, um, I can see these and then define that, okay, these images here have a grace period for the next 2 weeks, and so on, in my own policy, and then make sure that the team who's responsible for this is alerted on, and they can go about fixing it.
Cool. Sounds good. So running against the time here, but I guess while we're here and before we jump out, one question here that came in: how is Sysdig scanning different from other scanning tools? I think it's a good
Yeah.
question because scanning is a feature of a number of registries and so on. But so, what would you say, Pavan?
Yeah, I think that's a good question. A lot of the capabilities when it comes to the build phase, the CI/CD and registry, other tools can do it. But I would say there are two key things that we are different from the competition. That's unique. One is in the inline scanning. Right? We talked a little bit about that. So we go back to the slide. The scanning locally in the pipeline or the registry or even at runtime without sending the image or the registry credentials is unique, and that keeps your data safe. You have full control. So that's one unique aspect of a more safer scanning. And the second one is really at runtime mapping using the deep context that we collect from Kubernetes, the cloud, AWS environments, and using that to define better policies, better reporting of new vulnerabilities and mapping them back. That I would say is huge, big advantage for the customer.
Excellent. There's one more question, but I think we can ask or answer it when we get to the last slide. Before we do that, first of all, let me once again thank the audience for being here. And Pavan, thank you for going through that. I know when we first talked about doing a LinkedIn Live, it was like, well, should we do a demo or not? And I appreciate you doing that. We do want the audience to weigh in with any comments. Again, still have time for questions. But we're going to do this again, and we want to know which container security topic might be most interest to you. Like, what would you like to see next, maybe in January or so on? Compliance, number one. Do you want to more focus on how to achieve those kind of things? PCI NIST, runtime defense. We talked a little bit about runtime from an image scanning standpoint, but this is more thinking about now I'm running, and it has more to do with, I guess, intrusions and things like that. We can talk about that in the next session. Or number three, incident response and forensics. When something happens, and it will, to varying degrees, right? This is about how do you respond? How do you understand what happened with containers? So if you want to weigh in, great. We're going to probably do one of these topics next as a session. And so we certainly want to know what's of most interest to you. And if you flip to the last slide, Pavan, and here's probably where we can answer the question. The question was, how do I get started with Sysdig? And I think there's a couple ways, right? If you want to see more, we just looked at the demo of image scanning mostly today, but we're in the midst of AWS reInvent, and we're doing some more full-fledged demo sessions. There's a link here, and I think we've made that available to you. But you can certainly sign up to see one of those demos that are part of that whole reInvent show that's been going on and is going on for an extended time. The other way, and we'll see if you have any recommendations, but to get started is just trying doing a free trial. Since we are a SaaS platform, I think that's super easy, right, Pavan?
Yeah, exactly. Huge, and makes it easier for you as prospect or customer to get started and just deploy fast without dealing with the underlying management.
And actually, I think when you first opened the product to start the demo, it was right there, right? So once you have an account, that's what you get into, and you just it's like paint by numbers kind of a thing. So that's a good way to get started. It's really deploying an agent, and away we go. I don't know that we have anything else. But with that, I think we have successfully made it through our first LinkedIn Live. Once again, thank you to everyone for joining. Thank you, Pavan. Thank you for the organizers. If you have any parting thoughts, Pavan, let us know.
No, I'm all good. So hopefully you find the show interesting. And if you've seen anything with Systick, definitely check out the blogs, the content, and definitely sign up for a 30-day free trial.
Yep, and we can certainly continue the conversation on LinkedIn or directly with Sysdig. Visit our website, systig.com. Plenty of ways to reach out there. So thanks, everyone, and I think we'll close it out now. Appreciate your time, and hope you have a good rest of the day.